Welcome back, Cat 5 class. We're going to go over problem 819. So we're going to create our views and dimension it off of this isometric view. Okay, so let's take a look at this part. We can see we have these fillets, so these rounds. Notice how they're not dimensioned. Hey, what's the radius here on these fillets? Well, we have this note. This is something that's very common on a drawing. You'll see all fillets and rounds have a radius of 0.12 inches unless otherwise specified. So any rounds that you see that are not dimensioned, hey, we default to this note, radius of 0.12. If it's not 0.12, then it will be specified, right? Let's say it can be half an inch and it'll have its half-inch dimension. Its radius of half inch, for example. But since these don't have any dimensions, here it is. We follow this note, and again, this is very common note as used on drawings. We try and avoid using symbols, but this is one of the few exceptions. Or I should say we avoid trying to use letters and instead use symbols. So this is one of the exceptions. All right, so let's go ahead and take a look at this problem. Let's look at the 3D model. All right, so here are the round edges or fillets, right? As you can see, and they're 0.12 inches for our radius on this one. Okay, so one thing about this part is a part like this is actually poured into a mold. Okay, so this would be liquid metal, and let's say it's aluminum, and it's poured into a mold. And once it goes from a liquid to a solid, all this has a rough surface. So everything will have a rough surface, rough texture to it. But this piece needs to made up to other parts. So this is something that you commonly see on a car, for example. It can be something in the suspension, or a good example is like a water pump. So if you look at the old vehicles, not so familiar with the newer ones, but if you see the water pump, you'll see that like in an old Chevy or old Ford, they'll have a rough texture to it because it's cheaper to cast it into a mold. Take it out. Once it's solid, it'll have the rough surface. And then you can come in and machine off the surface. So you have a nice, flat, planar surface. So both of these will be parallel, not in the same plane, but they will be parallel to each other, and also in this case parallel to the base, to the bottom, because most likely something needs to attach to these surfaces, or I should say mate up to another part at these surfaces. And same thing with the bottom. Most likely it'll have to mate up with the other part and most likely bolt it together. All right, so let's take a look at the answer key. All right, so once again, this is a casted part. Again, you pour the liquid metal into a mold. It will turn into a solid. Then you take it out. It'll have the rough surfaces. Then you come in and machine. That's the reason for the little V, or the upside down V, right? These little V's indicate that this is machined off. So this is also going to have a rough surface. So you come in and machine it off. Right? Same thing with this one. It'll have a rough surface, and at the bottom, a rough surface. So you come in and just machine off a nice planar surface, a nice smooth surface, so it can easily mate up with its other parts, whether it's a vehicle or it can be another assemblies other than a vehicle. All right, so let's go ahead and create our front view first. So front and top is more than enough to give a machinist information to make this part, or I should say whoever is pouring the liquid metal into the mold, they know which mold to use for this one. All right, so let's take a look at the AutoCAD file. All right, so we have the front view done. It is missing the hidden lines and the center lines. Let's go ahead and first do our top view, and then we'll come back and finish off hidden lines and center lines. Okay, so just like the previous problem, we have circles. Okay, so if we go to the 3D model, here's the top view. Okay, so we need to draw circles and then connect the circles. Okay, so we'll go with the large diameters first, and then we'll do the holes. All right, so let's go back, take a look at the answer key. Okay, so once again, notice large circle is a solid. It's the shaft, right? Same thing with this one. So the large circles are shafts, so you do not dimension the circles, you dimension the rectangular view, right? So this large circle here is 1 inch in diameter, but you have to put the dimension here because this large circle is a solid. Same thing with this circle. It represents a shaft, a solid. So here is its diameter of 150. And then the inside circles represent a hole going through the shaft. So this is a hole, and we dimension the circular hole, right? Diameter 1. And this little circle is also a hole. As you can see, it goes all the way through. So here we do dimension the circle, indicating that it's a hole. All right, so let's go ahead and do the top view. So this has a diameter of 150, and this one has a diameter of 1. Okay, so we're going to use our construction lines. Okay, so let's go ahead and go to the visible layer, white visible object layer, draw our circles, and we're going to follow the center. Okay, so here's the center, here's the center mark, click and go all the way out to the furthest quadrant, right? Follow that endpoint or that vertex, click, go to the next circle, follow this center, there's our center mark, and click all the way out to represent the quadrant at that vertex. And there it is, and hit escape. All right, so now let's temporarily turn off our construction lines. Okay, so now we're going to connect the two circles using the line command and TAN, right? What? I said TAN for tangency. So once you click on the line command, right? Click on the line command, type in TAN, enter. Let's do the top portion first. Now we can see the green lantern ring, right? Click. Okay, there it is. You can see it's tangent to the top portion, and then we'll type in TAN again a second time, enter. And as long as you hover anywhere on the top half, it'll automatically make a tangent. Click. There it is. See how it made a tangent, and right click enter. Okay, let's repeat the same command. We can hit the space bar to repeat the line command. Type in TAN in the command line, right? And enter, and repeat at the bottom. We have the green lantern ring, click, my mistake, and type in TAN again in the command line and enter. And as long as you hover anywhere near the bottom half, it'll automatically make a tangent, and right click enter. And there we have it. Okay, let me turn on the construction lines. So in this case, we're not going to trim off the excess. Oh, I made a mistake. There it is, back on. All right, so these are round shafts, so we keep the entire circle. We're not going to trim off the excess, as you can see on the answer key. We're cheating, we're actually looking at the answer key. Now let's draw the little circles. Okay, so we have a 1 inch diameter and a 1/2 inch diameter. Okay, so using the circle command, let's go over to the object layer, the visible object layer. Okay, use the circle command, go to the center mark, and go to the construction line. There it is. Go to circle command again, repeat on the right hand side, go to the center, go out to the construction line. There it is. All right, so now we can go ahead and bring in our center lines. Okay, so center lines. Okay, so we have a center line for the two circles on the left. So let's go to annotate, draw our center mark, and let's pick the large circle, right? You want the center mark to go through both circular object lines. Same thing on the right. Let's pick the large one. There it is. And let's hit escape to exit. And we can extend one of them. Since this part is symmetrical, we can extend the construction line to go all the way through. Hit escape, and there it is. We have it. Now we need the vertical center lines representing the axes of the holes. Okay, so we can actually use the center mark If we want, you can use the center mark here, or center line. I should say center line option, click here. And we can just pick the two lines. And it automatically finds the center line. We can go ahead and extend this. Okay, let's do the same thing on this side. Let's use center line again. Select the two object lines representing the shaft. There it is. And we can go ahead and extend it. Okay, and hit escape to deselect. All right, so let's do our red hidden lines representing the two holes inside. So let's go to the red hidden layer, go to the home tab, red hidden layer, and use the line command. And we're going to go from the left quadrant of the inside circle, go straight down. Let's turn on ortho. There it is, vertical. Click and hit escape and then hit space bar to repeat the command. Come straight down. There it is. Hit escape or right click enter and then hit space bar to repeat the command. Goes all the way through. Right click enter. Hit space bar to repeat the command. Go straight down all the way through. Click and right click enter. And now we can use the grips to shorten the hidden lines to the correct length. Okay, let me hit escape to exit. All right, so for those of you that are wondering, hey, how do you change the gaps between the dashes? LTS, right? LTS. Not as easy as 1, 2, 3. So we can type in LTS if you want to play around with it. Maybe you want to increase the LTS. Go to the command line, LTS. And again, you wait till the very end. Once you've done, I know we still need the dimensions, but once you've drawn all your center lines, hidden lines, you can change the LTS, line type scale, enter. Currently it's set to 0.5. Let me go to 1, see what we get. And 3, 2, 1, don't blink, enter, bam. Okay, that's a little bit better, right? All right, so now let's turn off our construction lines, construction layer, turn it off, and throw in some dimensions. If you want to extend the center lines, go for it. They're too short. It's okay if you extend them slightly. All right, so let's take a look at the answer key. Okay, so this is our datum, right? We're going to dimension from the bottom up, bottom to the first step and bottom to the next step. Now, typically you would want to group dimensions together. If you go back to our chapter 8 lecture, right? We tend to want to group them together, but it just doesn't make sense to have the 150 over here on the right, because then we would need a long extension line. So we're going to take the oldest one, the 150, and just set it over here because it just makes more sense to dimension to this edge or this vertex versus putting it here and extending our extension line all the way up to this point. So it's better to keep this one on the left and these two on the right. Cool thing is you have the middle sibling taking care of the little sibling. All right, so let's go ahead and add these 3 dimensions using this datum. All right. Oh, teacher, wait a minute. You forgot the little radius here. I'm like, oh, yes, I did, right? I forgot the radii here. Okay, so let's include that radius. You can leave it alone, leave it the way it is. But if you go to the solutions, you can see we have these little radii here of 0.12. Radius. Okay, you can leave them out if you like, but I'm going to show you how to do it anyway. Okay, so we need a radius here. Okay, so I'm going to go to the white visible object layer. And we're going to do a radius. Gives us a chance to do a fillet. My mistake, a fillet or a round. So below the trim. Okay, so go to fillet. Okay, you want to know your radius. Click on radius here. So here's the word radius. Click on it. And we're going to use a radius of 0.12 inches. 0.12. Enter. We can don't click on the end on the intersection point. Click on the line. Click on the next line. Nope, not giving it to me. All right, it's okay. Let's do the one here on the inside. Oops, going on the wrong side. Let me hit escape. I should click on the inside here and then go up. I'm going to hit escape and exit, exit, exit. Let's do it again. Fill it. Okay, I should remember the radius that I use. Yep, 0.12. It remembers the last input for the radius. Okay, and let's hit enter for the radius and go from here to here. And there is the fillet. Now you do have the option to trim off the excess as you're creating the fillet. I'm just going to shorten this, hit escape. Okay, let's repeat the same thing on the other side. Okay, so I'm going to go fillet. And you do have the option to trim off excess if you want. Okay, so I'm going to go radius. Yeah, 0.12. It's already 0.12, so just hit enter. And I'll go from here to here. And then I'm going to adjust the length of these grips, or the line using the grips. There it is. Hit escape. And then you can add the next fillet. Let's see. Let's see if we can do it on this one. Couldn't do it on the other side, but let's see if we can do it here. Go from this one to, oh, it's not accepting it. So we're gonna have to try and, let me hit escape. I'm gonna try and trick it into creating a fillet. One way is to draw another line. At the end point, go straight up, and now we can draw our fillet. This line too. Oops, still not accepting it. I don't know if it doesn't. I don't know if the radii is too much for it. That's the reason it's rejecting it. Let me extend this further out. I think it's trying to tell me it's too short. Hit escape, or maybe it can be my trim options. Now I'll give up. Okay, so fillet, line, and line. There it is. It wasn't long enough. Okay, so now we can delete this line, this vertical. Okay, we can get rid of it. There it is. Do the same thing on the opposite side. So let's draw in a vertical line. A temporary vertical line just to help us create that fillet. Go vertical, go more than what you need. Right click enter. And let's go back to fillet, and it'll default to 0.12. And there it is, and hit escape to exit, and now we can get rid of this vertical line. All right, there's our fillets. All right, so let's throw in some dimensions. So from the base, let's go to our dimensions layer, and let's use linear dimensions, linear. So we got the oldest sibling. There it is, and now the little siblings on the right. Go with the small one first. Linear, so from this corner to, trying to get the quadrant here, there it is, 50. And let's go to the next one, the medium, or the sibling in the middle, right? There it is. And let's space it out a little bit more. You don't want this to look crowded. If you want, you can put the arrows in and take the text out, or take both of them out. Hit escape. Hey, that looks presentable. All right, so let's cheat and take a look at the answer key. Okay, so we got 150, 50, and 1. Notice how they're spaced out. You don't want them to be too crowded. Okay, let's throw in the diameters for the shafts, right? If it's a solid circle, you don't dimension the circle, you dimension the rectangular views. Okay, so let's go ahead and throw in these two dimensions. Before I do, let me space these out a little bit further out, just a little too crowded. All right, there it is. Hit escape on the keyboard. Okay, so let's throw in linear dimensions. Linear. From this point to this one. Same thing on the other side. Linear dimension again. Okay, we can throw in the diameter. Just simply double click on the text. Double click. Notice how it's blinking on the front. If not, you can always use the arrow pointing towards the left on the keyboard to get to the front. It's already blinking. And we can insert the diameter symbol. And click away. Ta-da! Do the same thing on the other one. Double click. And let's add the diameter symbol. Oh, I overwrote it. Okay, so let me hit escape. Oh. No, don't save the text. No. Okay, so here it is. So let me hit escape a few times. Make sure I exit. Okay, so I overwrote. You are allowed to overwrite the text. And it happens sometimes where you want to overwrite the text with something else, with a different dimension or maybe a note. Okay, so I'm going to double click. Okay, so I mistakenly clicked again inside. Notice how it's purple, but if I click inside the text a second time, just click once, see how it turns blue? The blue tells me that we're going to overwrite it, which I don't want to do. Okay, so let me just use the keyboard, the arrow pointing left to go all the way to the beginning or the front. You can see it's blinking on the front. And now I can insert the symbol at the front, the diameter symbol, and then click out in space to exit. All right, so we're almost there. And maybe pull this one outward a little bit. Let me hit escape to exit the command. Hit escape. Use the grips to slightly space it out. There it is. Hit escape. Make it look presentable. All right, let's see what dimensions we're missing. Okay, so the sides are not flat. They're round. So in this case, we're going to dimension center to center 475. And then we'll add the hole diameters. Okay. Okay, so we're going to dimension center to center using a linear. Okay, so linear. And we can go center to center. Or we can go from the end of the green center lines, green center marks, dimension from there. And again, try and keep the dimensions between the views. I think I forgot to mention earlier, but it is mentioned in the lecture notes. You try and keep dimensions between views when possible. Okay, now let's add the diameters for the holes. So diameter, click on the circular hole, click. Same thing for this one, circular dimension, and click. And if you're having trouble locating these diameter dimensions, you can simply turn off ortho, turn it off. By turning off ortho, now you can use the grips. It's easier to locate your dimension by turning off ortho. So you can see I have freedom to locate it wherever I want. And once again, you want the leaders pointing downward. We hit escape and towards the center of the hole. All right, so I'll leave it up to you if you want to add the note, but in a drawing like this, you would add the note. Note all fillets and rounds, radius of 0.12 inches, unless otherwise specified. I'm going to leave it out, but for those of you that are perfectionists, if you want to throw in that note, go for it. All right, so I think we're done. Let me double click. Actually, let me double check. Yeah, we have all the dimensions. If you want to throw in the little V's for machining, so again, the little V's tell us that this is a machine smooth surface, so it's not rough. And again, it's because most likely it's going to mate up. These nice smooth surfaces at the top and bottom are going to mate up with other pieces. And you want that nice tight seal with a nice clean machine surface and not a rough surface. All right, so that's the end of this video. Okay, so don't forget to save your work and see you in the next video.